Okay, today we are doing the paper chromatography lab. Right now I am setting up my filter papers and applying my solutions. I've already applied a few drops, but I'm gonna let you guys see the last drops being added. So what I'm doing is dabbing a toothpick in, putting a spot on the iron, and then for my testing piece of filter paper, I'm applying another dab of iron to each of these spots. I've applied and let it dry about 4 different times for each of the solutions. This one we're using cobalt. So dab of cobalt, each of these cobalt solutions, or each of these cobalt spots get a little dab. And then we do the same thing for the next one is copper. Okay, and the last one is nickel. Okay. Okay, and the idea is for each of these just putting lids on things. What we're going to do is we are going to take this, we are going to put it into our HCl and acetone solution, and we're going to let this soak for about 30 minutes, or until the solvent gets soaked up till near the top. We do not want to hit the top, but near the top. And then we're going to measure the distances. Okay, I have it folded so that it sort of kind of stays upright. Okay, and it'll fit nicely. Okay, so that's going to sit in there, and you can see the solution is starting to soak up, and the idea is when it gets to those spots that I've been put in there, it's going to pull this, the solvent is going to pull the compound with the ion up. I'm going to leave the plastic on top to keep this happy. And now what we're going to do is here's examples of ones from last year. We are going to apply different reagents to these test spots to see how they actually react. So the idea is those spots are going to move up as the solvent. You can see them kind of pulling them up, but the problem is that it's kind of hard to see the spots. Like through the light, you can almost see yellow, you can kind of almost see blue, nickel's a little bit green, but you need something to bring out the color so that it's easier to see. Our 4 possible developing reagents are KSCN, K4FeCN6, and DMG. So what I'm going to do is put a little bit of each of those onto each of these spots and see how the colors change. So at this point, you'll probably need to make note of what colors we get here. Okay. So, here we go. For the K4FeCN6, oh sorry, actually let's do the KSCN first. For the KSCN, I'm just gonna put a little bit on the tip of each of these. And we're gonna watch for a color change. Okay, so it turns very dark brown. Okay, for cobalt. Not much. Okay, for copper. Turns a very dark color. And for nickel, not a whole lot. So this would be a good indicator to determine if there's iron or copper, but it's not great for cobalt or nickel necessarily. Okay, so now we're going to try the same thing with K4FeCN6, potassium ferrocyanide. I can't get this out with one hand. There we go. All right, so now we're going to do the same thing and see what colors it changes. Iron turns a very pretty clean blue color, may be the best indicator for this one. Cobalt A little bit of bluish green, but not a lot going on there. Copper turns a kind of a reddish color, and nickel turns not a whole lot going on with nickel. Okay, and now we're gonna apply the DMG solution. This is dimethylglyoxine. Sorry. Okay. For iron, it turns kind of a reddish color, kind of a faint reddish orange color. For cobalt, it turns a light pink color. For copper, kind of gets just muddy color, doesn't really, not a clear indicator. And for nickel, you get a very nice pink color. So DMG is probably, we notice that nickel doesn't change a lot of colors, but DMG, it definitely changes to a nice pink color. It's easy to see. Okay. Now, these are not the only developing reagents we have. Some of these ones that might have been clear can be made to turn other colors if exposed to concentrated ammonium hydroxide. So I guess I'll pause for a second so you can make sure you see all the video, all the colors. Okay, zoom in a little bit. Okay, now what we're going to do is we're going to go expose this to ammonium hydroxide for a minute, just to see how the colors change and see if we can get any of these to develop better. Okay, so coming over here to the hood, concentrated ammonium hydroxide is pretty noxious stuff. So what we're going to do is I'm just going to take, let's do it this way. I'm just going to take a few drops. It doesn't take much, I just need it to get exposed to the fumes more than anything. And what I'm going to do is I'm going to set this in here. Look to see if any of these things change color. You see the nickel and the DMG turn really pink. The pink got really, really strong. Most of the other colors, not a whole lot's happening. So it seems like the DMG and the ammonium hydroxide is probably the best reagent to use for detecting nickel. It turns that very distinctive bright pink color. You'll also notice that some of the colors faded. This iron, which was really, really strong to begin with, kind of faded, so it's looking like maybe the potassium ferrocyanide is probably the best indicator for iron. The cobalt was pink to begin with and it kind of faded. So there's a couple different ways, a couple different sets of indicators we can use to detect each of these compounds. And get this out of here so we can get a better image of it. But these are what the developing reagents do to help us see what's going on here. Let's come back and see how this is progressing. I will probably stop the video and then just end up taking an image at the end, but I want you to see the progress at least a little bit. So you can see that it is pulling up the solvent is moving up the top, that's the mobile phase, and what's happening is each of the compounds are being pulled up, but not at the same rate as the mobile phase. Okay, not as fast as the solvent. Okay, you can see a little bit of coloration along the way, but it's still not perfect for detecting anything. What's going to happen at the end is when this gets near the top, I'm going to pull this out, let it dry on a piece of filter paper, and I'm going to circle each of those spots with a pencil, and then I can expose it to each of the different developing reagents, and we'll see what happens. All right, thanks.